Hi everyone. What if you could predict whether this new candle will be red or green even before it happens? Wouldn't that be really cool? I built a machine learning algorithm to predict just that. In this video, I'll walk you through how I built the algorithm and what the results were. Stay till the end of the video to figure out what the results were and can you actually predict every candle. So let's walk through step by step how I built the machine learning algorithm and what I learned by building this algorithm. So this is the notebook and you can download, I will give you a link to this notebook. You can download this notebook and play with it yourself, and you can improve this algorithm by yourself and see whether you can predict the next candle as well. So the idea is pretty simple. Um, Here we have some candlestick data, that is the history of prices of a instrument. In this case, this is BTC or a Bitcoin. And the idea is that we will take one candle like this and we will try to make a prediction of whether this is going to be red or green. So this is going to be a classification task in machine learning, a binary, what we call a binary classification task. So there are two labels, red or green, 0 or 1 equivalently. And we will use all the data that we have from, the past, all the past data that we have before this candle. Any way we, in any shape or form, we can use this past data. Let's say, how many red candles were there in the last 20 candles, or the slope of the lines before this candle. And that is sort of these creativity here, is that how can we come up with these interesting features which will help us predict whether this candle is going to be green or red. So now that we have a basic idea of what the task, machine learning task is, let's get down to the actual uh, execution of this notebook. So let's see. So first we import some stuff. We install the TA, or the technical indicators library, which we will see how that is useful. And now we get down to, first we set the random seed because we want our randomness to be sort of deterministic. And finally we get down to getting our data. If you follow this channel regularly, you know that one data set that I often use in many of my sort of adventures in sort of algorithms is this data set on BTC sometime around 2024 when BTC was around 65K. This is I have it in a CSV file. I download it, and this is what the data looks like. It's a 5-minute interval BTC data. As you can see, the intervals here, between successive rows, we have 5 minutes, and we have sort of open, high, low, close, and volume, and the rest of the stuff is not that important. I also calculate the mid by taking the average of the open and the close, but the rest of the stuff is stuff that I just use for utilities. So that's where we are. Now, what is the next task? The first task was to get the data, which we have. Now the next task is to build our features and label. How do we end up doing that? We use the TA library, and the TA library has this really handy feature that I'm going to use a lot more in my next few videos as well, as you will see. But this is a really handy feature which basically gives this data frame and gives which is the column that corresponds to open, high, low, close, and volume, because it takes candlesticks data and it adds all the technical indicators features in the library in one single go. Where do we end up? We look at the df.columns. Where are we? We have these original columns that we had in our data set, but we've added a lot of these technical indicators columns, which at one go without doing complex calculations of each of these columns. As you can see, there is sort of volume indicators here. There are volatility indicators here. There are sort of trend indicators here, momentum indicators. Some of these are very obvious to you. So for example, the trend SMA, fast and slow, EMA fast and slow, you know these indicators very well. if you follow this channel regularly, there is the RSI somewhere. Here is the RSI. There are a bunch of other indicators that you will recognize. There's VWAP. There's also other indicators that I frankly don't know what they are. But here we are with all of this. First, we define the label. It's really easy. We say if the close is greater than the open, the candle is green. What does that mean? Here we have some data. Here we have a candle. If the close is greater than the open, that's a green candle. If not, it's a red candle. It's very simple. And yeah, so we wanted a 0 or 1, so we say as type equals to int, so we go from a boolean to an integer. This is very important. We shifted by -1. Why? Because our label is the label of the next candle. So every row here is a candle. We have open, high, low and close. But we want to know what the label of, we want to predict whether this candle is green or red, whether this row is green or red with the data that we have for this row. So this is our row which we will construct the features from, and this is the next row. So we will need to shift the is green by -1 so that we get the label at the proper place. If you don't do this, you will get 100% accuracy, and it's very important to see, to remember this. That is sort of leakage of data from your features. So now that we fixed the label, we know green or red, we've shifted the label properly in time, and now it's time to standardize our features. The problem is that even if we have all of these features, they are not standardized features. They vary a lot between these rows, and if we want to do any kind of machine learning using this data, we have to standardize these features in some way. So the first thing that we do is to create some Boolean features. We know that, if the fast SMA is greater than the slow So we know that if the fast SMA is greater than the slow SMA, that is a trend signal. Similarly, if the fast SMA is larger than the fast EMA is larger than the slow EMA, that means we are trending upwards. Maybe that indicates that the next candle is going to be green. Maybe. That is our hunch. So we create this feature. Similarly, if we know that the price is above the SMA and the closing price is above the EMA, those things indicate that we are in an upward trend. So we use these features as Boolean features, and again, we convert them to integers so that it's 0 or 1 instead of true or false. And these are our features that we have created, and these are standard features. These are not depending on the actual value of the fast and the slow EMA, which can differ between one row and the other. And then we take some of the previous prices, which we will use in the later sort of part of the feature engineering. Then we create even more Boolean indicators. Is this particular row red or green? So maybe, if my current row is red or green, that determines whether the next candle will be red or green. So we take that as an indicator. And then we go even more. We say, is RSI overbought? Is RSI oversold? And we create a bunch of other indicators which are Boolean indicators. Finally, we take these candlestick patterns. We know that people look at these individual candlesticks. These are patterns that we discover from individual candlesticks. Is this a gap up? Is there a gap down here? Is there an upper wick in the candle? Is there a lower wick in the candle? These are things we calculate because we believe that these individual candlesticks patterns can have some predictive power. That is what we learn from technical analysis. And we will see whether this actually works out when we train and test our machine learning algorithm. Similarly, we create a bunch of indicators from volume, volatility, and then we also create some normalized features. The MACD itself can vary a lot between the rows, but we so this is important. So the reason we create these normalized features is because machine learning algorithms are known to perform better with scaled features. So if these features, the normalized MACD is between 0 and 1, but the MACD itself, which is this feature here, is not between 0 and 1. If our features are between 0 and 1, if they're scaled between 0 and 1, a lot of the popular classification algorithms are supposed to perform better, especially logistic regression. So that is sort of common knowledge in machine learning, which is why we create a normalized sort of set of features from our feature set. And then that's sort of where we are. Now we think about some other features we can create based on our intuition. One intuition we have, how many greens in the last n candles? So if we set n equal to 5, like how many greens are in there in the last 5 candles? So if we go here, if we see that, the last 5 candles are all red, what does that mean? Is that an indicator whether the next candle is going to be green or red? That is the question we are asking. We say, this says in close greater than open and calculate the rolling sum of that. That tells you, how many green candles are there in the last 5 candles. Finally, we try to figure out what is the position of the open versus low. What is the position of the opening price as opposed to the high price? So is like, this is, the question is whether this high price here is close to, or sort of the open price. The question is the open price here, how far is that from the high price? That is what we calculate here, and same for the closing price. Now we have a bunch of columns here. The only thing that remains to be done here is to make sure that there are no NANs. There is some NAN here because what happens is that we calculated the previous open and the close prices, but those are not defined for the first row because the first row never had a previous open or a close, which means that we have some NANs. If we have these NANs or not a number, like then the machine learning algorithm won't work. So we have to remove those. Anyway, now we choose a bunch of features. I played around with this and this is what I arrived at. It's kind of where we are, but you can play around as well. You can remove some features by, just doing this, or you can again add them by just uncommenting it. But that's kind of where we are. And this is where we are at the end of the day. Okay, I did a small trick here, which I will explain why. I went from the second row, the third one. I'll explain why. But in the end of day, we end up with this data frame. The first thing is like, is the candle green? We have a bunch of 0, 1, 0, 1. Is the fast SMA larger than the slow SMA? Is the fast EMA larger than the slow EMA, and so on? These are Boolean sort of features, and then we end up with these floats, which are these normalized features, and then we have a number of green candles in the last 5 candles, and so on and so forth. And this is the label we have, which is the next candle green or red? If it's red, it's 0. If it's green, it's 1. Now it's important we don't have any NANs, and we discovered that we have some NANs, which is because, again, the previous, like the first couple of rows are a little problematic because sometimes we use the previous row to calculate things which especially like VWAP requires, some averaging. So if we remove the first 2 rows, which we did, which is this df small, which removes the first 2 rows, and the last one, we end up with no problematic sort of rows. Now we will use 3. So we've got our data. We've done a bunch of feature engineering. We added a huge number of features. We try to do a bunch of things which we intuitively think is going to help. So finally, we define our ML algorithms. We have 3 ML algorithms we try here: random forest, gradient boosting, and logistic regression. This is not a machine learning video, so I am not going to explain what they are, but they're very popular classification algorithms, which you can look up and which you already know if you know some basic machine learning. Now the important part, we're going to divide training and test. The first 70% of the data is going to be used for training, and the next 30% is going to be used for test. It's important in financial candlesticks data to do this not randomly. because we don't want to use information from the future. So we want to use, the first sort of 70% of the data to train and the next 30% of the data to test. We don't want to sort of randomly find candles to test, because then we're going to use data from the future to predict the past, which is not okay. So those are the important things you should remember when we try to do machine learning on candlestick data. So now we know the features are, we create sort of X and Y matrices, and then we first use random forest. Where do we end up? We have two things, model accuracy and ROC AUC. ROC AUC is a better measure which takes care of the imbalance in data. If your data is imbalanced, if you have more positives rather than negatives or more negatives compared to positives, the ROCAUC is a better indicator compared to the accuracy. In this case, it doesn't matter that much because we have almost similar-ish red and green candles in the test data set. So what do we see here? We see that accuracy and AUC are very close to 0.5. What does that mean? It means our machine learning algorithm is not very good. It's predicting 0.5 means random. The predictions are random. We are barely better than random, 0.51. One more thing we can check, which is what are the feature importances. We see that these normalized features look really good. Those are the features that random forest thinks are really important in this algorithm. Those are things we want to know if we, maybe we should use these features if we were to create a better algorithm to predict these prices. Now we look at what happens if we use some other algorithms. Gradient boosting, another very popular machine learning algorithm. We go through the exact same steps. We're even worse. We're very close to 0.5, which means that gradient boosting basically predicts like completely randomly. Again, we look at these feature importances, the normalized RSI, the normalized, this is the Bollinger Band, MACD, VWAP normalized. Those are the ones that are important, similar to random forest. Finally, we use logistic regression. Logistic regression doesn't give us feature import, but interesting to see, but the logistic regression actually gives us a better score. But is this that better? It's still very close to random, which means that whatever we do, whatever algorithm we use, all the attempts that we made with all these complicated way to standardized features, we had a lot of intuitions on, whether maybe the next last green candles may be useful, and so on, and like whether the wick there is a gap up, gap down. But at the end of the day, we see that it's almost random. Maybe we can try a couple of things. I will try one more thing live here, which is to remove some features. Maybe if we remove these, if we only have these Boolean features, maybe we can try that and see what happens here. Let's try it. Okay. And then I think this should be fine. Yeah, the X and the Y. This is what we should change. Okay, that's even worse. It's even worse, basically. Maybe this is not a good idea. Removing these normalized features is not such a good idea. Maybe what happens if we remove some of the Boolean features? Maybe we'll remove these Boolean features here. Only have some of the normalized features. You see how I have made it very easy for you to sort of test out these things, and in your machine learning algorithms, these things will matter more. Okay, again, not that good. Maybe removing these features is not a good idea. What about adding a lot more of the Boolean features? Would that help? We had these last 3 rows. Maybe some of them will be, helpful. Let's try. Okay, random forest. Not really. Our initial selection was better. The reason it is better is because I had tried all these things before when I was sort of constructing the notebook, and I was trying to find the best possible sort of configuration. So that's kind of where we are. What did we learn from this exercise? What we learned from this exercise is that it's really, really hard to predict the next candle. That is a very difficult thing to do because stock market data is inherently noisy. It will be very difficult to predict every candle. It would have been, you could be a millionaire in like, one day if you could predict every 5-minute candle, but that is an incredibly difficult task. And we fail at the task, which is not surprising. But that is one sort of thing to take away from these is that if someone tells you the technical analysis can do this, probably not. Probably not. Maybe we missed some important features. You can try to add some important features. We have all the framework here. Maybe you can try to add some more features here, and maybe then we will see a better result. And I will leave it up to you. Like, comment and below if you can sort of improve upon this. Thank you, and please like and subscribe this video if you like ML algorithms and stock market data.